All right, so I want to continue with what we were talking about yesterday. And you will see what we're talking about today. So I need you to pay attention to how things are going to be written. We did long division yesterday. So let's look at these two examples on the front of this. It says, step 1, divide the first term of the dividend by the first term of the divisor. Is that what we talked about yesterday? Just taking the first term and dividing it? All right, so we're going to do 2x plus 1. And I have 6x cubed minus 13x squared plus 14x plus 4. Now, we're going to talk later today about synthetic division. The only way you can divide this one is with long division. There's no other way to do it. That's why we start out with long division. Now, we're looking at the first term. So what is 6x cubed divided by 2x? 3x squared. And then I multiply, and I get 6x cubed plus 3x squared. And what do I do here? I'm going to subtract. All right, and so I get negative 16x squared, and I bring the rest of this down. Then I look at the first term again, negative 16x squared divided by 2x, and what do I get? Negative 8x. So negative 16x squared minus 8x. I'm subtracting. They cancel. What is 14x subtract negative 8x? 22x. And then your first term, 22x divided by 2x is, so I have 11 times 2x is 22x, and 11 times 1 is 11. I subtract. I get negative 7. This is a remainder. So that would be subtract 7 over 2x plus 1. Now, if I ask you, is 2x plus 1 a factor of 6x cubed minus 13x squared plus 14x plus 4? Is it a factor? Is 2x plus 1 a factor of this? No. Why? Because it has a remainder. Like, is 2 a factor of 8? Yes, because 2 divides evenly into 8. Is 3 a factor of 8? No, because you would have a remainder if you divide it. All right? So it could just ask you, is this a factor of this? Does everybody understand? If you have 0 for your remainder, then it would be a factor. All right, so let's look at number 2. So I'm going to write it out. What is different about this one? Goes to the 4th power. What else is different? Do what? I think you're right. I think you're right. There's no x in there, is there? So what do we put?
0.
We put a 0. So I have all right, so look at the first term.
Why did you just put that 0?
Because there is no x. You got to have it. It's what we did yesterday. So you got to have it so when you are subtracting, you're lining all your stuff up. So if you're missing a term, you need to put a 0 there. Does everybody understand that? If you're missing a term, you need to put a 0 there to keep your stuff lined up. And what we're getting ready to learn, you have to put a 0 there. All right, so first term, 5x to the fourth divided by x. 5x cubed. Then I multiply 5x cubed times x is 5x to the fourth, and 5x cubed times 1 is 5x cubed. And I subtract. So negative 6x cubed plus 2x squared then I take the first one. Negative 6x cubed divided by x is negative 6x squared. Guys, I'm not going to keep asking you to put your phones up. I'm just going to take them. We're on like day 30 in here, and there's still phones out. Does everybody understand? Negative 6x squared times x is what? Negative 6x cubed. Negative 6x squared times 1 is and I subtract. They cancel. 2x squared subtract negative 6x squared is 8x squared. Do you see that I'm keep repeating the same thing?
Yes.
First term, 8x squared divided by x is just 8x. All right, 8x times x is 8x squared, and 8x times 1 is 8x. And because I have that 0 there, it's lined up, and it just makes it easier to make sure of what I'm subtracting, because you can only subtract like terms. So 8x squared subtract 8x squared is 0. 0 subtract 8x is negative 8x plus 1. All right, negative 8x divided by x is negative 8. And negative 8x subtract 8. And I get 9. So I get plus 9 over x plus 1. Does everybody understand what happens with your remainder?
Yes.
All right, so now I want you to turn over and look at the back. And these are our two theorems. All right, what this says is, the remainder theorem, if a polynomial function, p of x, of at least the first degree is divided by x minus a, where a is a constant, then p of a is equal to the remainder. Okay, so what that means is, let's look at number 2. If I have, this is from example 2, p, now it says x minus a, so what would my a be if I had x plus 1? If it's x minus a, what would it be? Would it be negative 1? Is everybody with me? So if I had p of negative 1, I want you to take negative 1 and I want you to substitute it for your x in this function right here.
Every x.
Every x. So you would have 5 times negative 1 to the 4th. Make sure you put your negative 1s in parentheses. What'd you get? Guys, you're just putting something in the calculator. That's all I've asked you to do. Some of y'all still weren't doing it.
I wrote mine on paper. I don't know why. Is it 9?
Thank you. Guys, y'all can't do the easiest stuff because y'all don't know how to put it in the calculator. And I'm sitting here and like 4 people are putting it in the calculator. And so when you go to take a test and it's going to ask you what P of A is, and you don't know how to do it because you didn't know how to put it in the calculator, you missed the easiest problems on here. Because half of you wouldn't put the -1 in parentheses, or you wouldn't do things like that. Guys, you've got to do math. This is not a spectator sport.
I didn't know it was sport.
There's one in every crowd. All right, did you get 9?
Yes.
All right, is that what your remainder is?
Yes.
All right, so that is what the remainder theorem is telling you. So P of -1 is 9.
Where did you get the -1 from?
Because x minus a is what you have right here. We divided by x plus 1. So my a is -1.
Okay.
So all you do is find P.
P is given. P is the function. P is this function right here.
But like 9. When you just got 9, is P of 9 equals, or
If it asks you that, yes. This is always going to be equal to the remainder.
okay, so that's the answer for P basically. Or P
If
-1.
it just asks you, then P of A is equal to the remainder. If it asks you what P of A is, or P of -1, or if it asks you what the remainder is,
Okay.
then you can just do that.
Is it always going to be a -1, or can it be a different?
No, it can be any number.
Okay.
Okay. All right, so the next theorem is the factor theorem. Guys, I need you to pay attention. I mean, I'm answering the same questions over and over because the same people aren't paying attention. I don't mind answering a question, but it's because you're not paying attention. All right, your factor theorem. We have the expression x minus a is a factor of a polynomial function if and only if P of A is equal to 0. Is that what we talked about when I was asking you is something a factor? It's a factor because there is no remainder. Does everybody agree with that? All right, so that is what this theorem here is telling us with the factor theorem. If I was to, I want to know if this is a factor. What is my A for this one? I'm dividing by x plus 1. What is my A?
-1.
It would be -1. So I want to know what P of -1 is.
Wait, so why isn't it positive or negative?
Because it's A x minus A. So it's always going to change signs.
So if
So
it's
I-
a negative and it's x minus a, will we change to positive?
Yes.
So when we find out what the remainder is, we find out what the remainder is in this part, right? So that we put -1 into the x of all of them, and then we divide it by x plus 1. Well, -1 plus 1.
We're not dividing here. All we're doing is talking about the remainders. I mean, I'm not asking you to divide. I showed you this one right here, and that gave us the remainder, which is what we had right here. So a question could ask you, what is the remainder? And all you would have to do is substitute your A in instead of doing the division.
So that's basically to check if you got your problem right, or your remainder right.
You can.
Oh,
Yeah.
I thought this was a whole other.
But the question can ask you like this. Let P of x equal this. Is x plus 1 a factor of P of x? So we know that A is -1. So now put in -1 into this function right here. And tell me what you get. Did you get 0? All right. So that means that x plus 1 is a factor of this. That can just be the question. Is x plus 1 a factor of p of x? And it would be yes. Does everybody understand that?
So when I ask a question like that, you just find the x, and then you plug it in for, or you find the a and you plug it in for all the x's?
Yes.
So it's always gonna equal 0?
If it is equal to 0, then it is a factor. If it is not equal to 0, like when we got right here, if it asks you if x plus 1 was a factor of this, no, because we have a remainder.
Oh, okay.
Okay? Is everybody with me there? Okay? So that is what these two theorems mean. It's just kind of a short way to ask you if something is a factor. Everybody got that? All right, so I want you to finish 1 through 8. What number are y'all on?
I'm finished.
You're finished? Okay, you're finished. All right, I'm going to give you a couple of minutes to go over that because then I want to show you synthetic division.
Are we finally doing math 3 words?
I haven't told you any of this, guys. This is your notes that I just gave you.
This is so much work, man.
Welcome to my 3.
I can't remember none of this junk.
Well, you got to do your work. You can't sit there and sleep.
I'm trying to be a visual learner. If I write down copying what you're doing.
I'm not talking about that. I'm talking about when I just gave you 30 minutes to work on something and asked you 4 times to do your work. Well, I mean, you can ask questions. That's what I'm here for. I mean, if you don't understand something, you have to ask. All right, guys. I want you to look up here. I am on number 3. Well, I mean, a lot of people are finished with the first page. All right, now, I am going to show you another way to divide polynomials called synthetic division. It is easier, it is faster, it just doesn't work for every polynomial. Does everybody understand? The only time you can use synthetic division is if your divisor right here is just like 1n to the first power. Meaning, I could not use synthetic division with number 2 because it's 3a. Does everybody understand? So this just has to be 1x to the first power. Does everybody understand? If it is x squared, you can't use it. If it is 4x, you cannot use it. You have to use long division. Okay? Now, I want you to pay attention to setup. This is your box. And we're going to put our a in the box. We have n plus 5. What is our a? We just talked about it. -5. And then we're going to put our coefficients going across. So I would have a 1, I have an 11, and I have a 25. All right, this is the setup. If you are missing a term, you must put a 0 there. On long division, you don't really have to. We did it just as a filler to keep our stuff lined up. Synthetic division, you have to. All right, then we skip a space and draw our line. Now, underneath of our constant, I'm just going to kind of have a diagonal line. So here is our setup right here. All right, you bring the first term straight down. All right, and then I multiply. -5 times 1 is -5. It goes right here. Nope. Synthetic division, you're going to add. So I have 11 plus -5 is
16.
And then -5 times 6 is -30. And I add. Is everybody with me? So, -5 times 6. So, what I have done is I've put my A in the box, which is just this one here with the opposite sign. I have put my coefficients across the top. I bring the first one down. Whatever it is, you bring it straight down. And then I multiply. -5 times 1, -5. And I add. -5 times 6 is -30, and I add. And I would keep doing that as long as it went. Now, my answer is I go down 1 degree. Remember talking about degrees of polynomials was the exponent? I go down 1 degree. If this is squared, 1 degree going down would just be n, correct? These are the new coefficients. So I would have n plus 6, and whatever is under your constant is your remainder. Subtract 5 over n plus 5. Now, I personally would do synthetic division whenever I could. But you can't do it for all of them.
Where you, I get when you got the +6, where did you come from?
This is a 1. So it's like 1n.
Oh.
Would I get the same answer if I did long division? Yes. All right, so look at number 4. What is my A? 7. Alright, and then I'm going to put my coefficients. So I have 1,
Can't see it.
-3, -20. You have to watch your signs. That's the biggest thing on this. So there's your setup. You have your A in the box, then you have your coefficients. All right, you bring the first term down, and then you multiply. 7 times 1 is 7, and you add. 7 times 4 is 28, and you add. This is squared again, so you go down 1 degree. So I have y plus 4 plus 8 over y subtract 7. I would do this before I did long division. But we did long division because you can't do it for this for all of them. All right, let's look at number 5. What goes in the box? -2. My coefficients, 3, -1, and -20. Is everybody good on the setup? All right, bring the 3 straight down. -2 times 3 is -6. And you add. -2 times -7 is 14. And you add. So this is k squared. So it would be 3k subtract 7 subtract 6 over k plus 2. Do you like this way better?
Yes. Your signs are very important.
Very important.
Good God.
Guys, if you miss one sign, you miss the whole problem. Okay? So it's no longer I just forgot the negative, because it can mess up everything. All right, let's look at number 6 because it's cubed. What goes in the box? -5. And I have 1, 2, -22, and -45.
Miss Braxton,
Yes, ma'am.
do you have Mackenzie Branson?
She is with the band.
Band, okay, thank you.
All right, is everybody good on the setup? All right, bring your first term straight down. -5 times 1 is -5. What do you get when you add? -3. -5 times -3 is positive 15. And I add. -5 times -7 is, and I add. You see why you have to put the zeros in here now? If you don't put the 0, it moves your,
Where do you put a 0?
I'm just saying if something was missing, like in the
Oh.
other one a while ago.
Oh,
It's not mandatory in long division. I do it to keep everything lined up, but in synthetic you have to. All right, where am I going to start this time? X squared, because we go down 1 degree. So I have 1x squared, subtract 3x, subtract 7, subtract 10 over x plus 5.
So I messed up on 5, I just put positive 2 in the box instead of negative 2. That's
And
fine.
it, yeah, all right, let's look at number 10. What's happening with number 10? It's missing the x squared, right? All right, so what's going to go in the box? This is really hard to see. Hold on. All right, so what goes in the box?
So with the 1 0 be positive.
Do what? All right, so what's going to go across here for my coefficients? 2. Nope. You got to have a 0 because you're missing x squared.
Oh, okay.
Then negative 14, 10.
So it got to be squared in order to work with it?
If it has to go down every time, it has to go in descending order, and you have to have something for every term.
Alright,
So if this is cubed, you're going to have 4 terms. If it was to the 4th power, you'd have 5 terms. And if something is missing, you have to put a 0 there. All right, bring down your 2. All right, negative 3 times 2 is negative 6. And you add. Negative 3 times negative 6 is 18. And you add. Negative 3 times 4 is negative 12. And you add. All right, so where are we going to start? All right, so my answer is 2x squared minus 6x plus 4 minus 2 over x plus 3. Very good. All right, and I want to look at one more. Let's look at number 12. What goes in the box?
positive 4.
Positive 4. What goes across the top? 1, 0, negative 7, negative 32, negative 15. Guys, don't forget the 0
Why is the 0 before the negative 7?
because I'm missing a cube. See, it goes from 4 to 2. So it's
Oh.
0x cubed or p cubed.
So it has to go in order.
It has to go in order.
See, I didn't know that.
Yeah. It has to go in descending order. Does everybody understand that? You see where the 0 goes? Because we have 0p cubed. All right, so bring down the 1. 4 times 1 is 4. And I add. 4 times 4 is 16. And I add. 4 times 9 is 36. And I add. 4 times 4 is 16. And I add. Where's my answer going to start? All right. X is fine, it's p's, but p cubed
You can't see.
So I have p cubed plus 4p squared plus 9p plus 4 plus 1 over x minus 4. And that is my answer.
So it's not P minus 4?
Oh, p, yeah, sorry.
I noticed that. I got like three variables in one problem.
Yeah. It's the variable they use. If I write the problem, I always use X.
That's what I'm the same way.
If you were to give me this answer with X's, I know what you mean. All right, does everybody understand that? Your assignment is to finish that worksheet that I gave you at the beginning. On the back, it just says to divide. They are missing terms, I will tell you that. For number 9, I would do synthetic division. For number 10, can you do synthetic division? No, you cannot. Why? Because it's got 2x. All right? The ones that could do synthetic, I would do synthetic. Does everybody understand?
You can only do synthetic for number 9?
No, I would do it for 9, 11, 12, 13.
Yep, okay.
You can't do it for 10 and 14.
That's home?
Oh, never mind.
Yeah. Yeah.
So your assignment is to have that worksheet finished.
So what we could just do is call it
Synthetic division.